Hi, my dear student. Today we will start new lesson, resistors connections. How to connect resistors in any circuit? By two ways, in series or in parallel. These are two methods to connect resistors in any circuit. Let's talk about the first method, series. Series by like that. This is the first resistance R1. This is the second resistance R2. This is the third resistance R3. Connected to ammeter and power supply or battery. Okay. V. In this circuit, we see the current I. This is the same current I1, here I2, here I3. We see the current is the same. So in series, current is constant. Current is constant, not divided. So I equal I1 equal I2 equal I3. But the potential difference across first resistance differs than potential difference across second resistance differ than potential difference across third resistance. Okay? So, total volt or total potential difference across the battery must equal potential in first resistance plus potential in second resistance plus potential in third resistance. As we know, V, Ohm's law, equal RI. This is the total potential. This is the R total. Okay? Or sometimes we can write it R dash I. V1 equal I R1, V2 I R2, V3 I R3. Take the four equations in the first equation. So we can change V by R dash I equal V1 I R1 plus I R2 plus I R3. Okay. I can neglect I. So total resistance in series is a summation of resistance. This is the total resistance. Okay. If we have n numbers of resistance, like that, all resistance have the same value. So R total or equivalent resistance equal a number of resistances times the value of one of them. This if all resistances are equal. Okay. From this we saw or we see in the equivalent resistance must be greater than any of resistance. Total resistance must be greater than any of any resistance. Okay? Okay. Let's take problem. Three resistances, 85 ohm, 70 ohm, and 25 ohm, are connected in series with battery. So R1 equal 85 ohm, R2 equal 70 ohm, R3 equal 25 ohm. In series with battery, V equal 45 volt. Calculate the electric current intensity path in 3 resistors. He wants to calculate I total or total current and the potential difference across each resistance. We need to calculate V1, V2, V3. How? First, the resistance is connected in series. So, R dash or R total equal R1 plus R2 plus R3. R dash equal 85 plus 70 plus 25 equal 180 ohm. This is the total resistance. So, V equal R dash I. V equal 45 equal 180 times I. This is the total current. Okay? By calculator, we can find I equal 0.25 ampere. Okay. V1 equal R1I equal R1 85 times 0.25 equal 6.25 ampere. V2 equal R2I equal 70 times 0.25 equal 17.5 ampere. V3 equal R3I equal 25 times 0.25 equal to 1.25 volt. Sorry. This is volt, not ampere. Potential in volt. Okay? Okay, so good. We can return, okay, sorry for these values, okay. The first one is 21.25 volt, this is 17.5 volt, this is 6.25 volt. I check my calculator and get it, okay. The second way to connect resistors is parallel, okay. How? Like this. Is the first resistance, second resistance, third resistance, okay, and here battery, okay. This is R1, R2, R3. Here the total current I must be divided in this point or junction. Here I1, I2, I3. Okay, and this is the potential of battery V. In this case, potential is constant. So V equal V1 equal V2 equal V3. Okay, and current is divided, so I equal I1 plus I2 plus I3. From Ohm's law, I equal V على R dash. This is the total current. I1 V على divide R1. I2 V divide R2. I3 V divide R3. Take the four equations and substitute in this main equation. So V divide R dash equal V divide R1 plus V divide R2 plus V divide R3. V, okay. 1 over R total equivalent equal 1 over R, 1 plus 1 over R2 plus 1 over R3. Okay? This is a total resistance. Okay. This is the equivalent resistance. Okay. In case special cases, if we have two resistance in parallel, R1 and R2, so total resistance R dash equal R1 times R2 divide R1 plus R2. Take care. In this equation, after we calculate 1 over R dash, we must invert or reciprocal it. We want R dash, not 1 over R dash. Okay? We want a R dash. Okay. If we have n resistance with the same value, so R dash equal R divide n. From here we see the total resistance must be less than of the smallest resistance. R dash less than the smallest resistance. Okay. We have two questions. Give reason. Why home appliances are connected in parallel, not in series? Why? Because in parallel like this is like TV, refrigerator, cook, okay? If one of devices are broken, not affect of other devices. And if we put power supply 220 volt, the same volt in TV, the same volt in refrigerator, same volt on cook, okay, or oven. So we connect home appliances in parallel to obtain constant volt, and if any device is broken, not affect on the other. Okay. Another question. Why this is a battery? This is a wire to connect resistance, okay? The wire here or here must be thick. Why? And this is maybe thin. Why this wire must be thick? Because in this branch and this branch here I total total current is huge value, and at this point divided into 2 or 3 or 4 amounts, okay? So the current in wire from battery may be huge, the maximum value, and divided at this a connection. So the wire connect resistance may be thin, but the wires in terminals of battery must be a thick. Okay? Let's take a problem. From opposite circuit, find the total resistance. The first one, A. R1, 25 ohm, R2, 70 ohm, R3, 85 ohm. Here the resistances in parallel. So 1 over R dash equal 1 over R1 plus 1 over R2 plus 1 over R3. 1 over R dash equal 1 over 25 plus 1 over 70 plus 1 over 85. By calculator, shift solve, we can get R dash equal 15.14 ohm. Okay. The second is, okay, we get it. The current intensity in each resistor. We want to calculate the current intensity in each resistor, I1, I2, and I3. How? Okay. As we know from Ohm's law, I1 and potential is constant, okay? Equal V I1 V divide R1. So equal 45 divide 25, okay? By calculator, equal 1.8 ampere. I2 equal V divide R2 equal 45 divide 70 equal 0.64 ampere. I3 equal V divide R3 equal 45 divide 85 equal 0.53 ampere. Okay, we get the B, C, the total current intensity. Total current intensity I. We have two ways to calculate it. The first one, I total equal V divide R dash equal 45 divide R dash 15.14. Okay, equal 2.97, or I total equal I1 plus I2 plus I3. 1.8 plus 0.64 plus 0.53 equal must be give the same result, ampere. Okay, good. Third problem. 3 resistors 20, 40 and 60 are connected to an electric source. If potential difference at terminal of each of them are 50, 20, 30. Okay. Illustrate by drawing how are these resistors connected. Then calculate the total resistance, R total. Let analyze this problem. R1 equal 20 ohm, R2 equal 40 ohm, R3 equal 60 ohm. Volt in first resistance is 50. Volt in second resistance 20 volt. V3 equal 30 volt. Okay. In the problem, not clear how the 3 resistance are connected, but we can see good thing. What? The summation of these two potentials equal 50 equal the V1. Okay, so we can conclude both of R2 and R3 are connected in series like that. R2 or R3 and R1 in parallel with them. Why? Because the potential on R1 must equal total potential on R2 and R3. This is the drawing of the circuit. Okay. How we can calculate? Okay. There another way to check this. Okay. what? I equal V divide R. Okay. So I1 equal V1 divide R1 equal 50 divide 20 equal 2.5 ampere. I2 equal V2 divide R2 equal 20 divide 40 equal 0.5 ampere. I3 equal V3 divide R3 equal 30 divide 60 equal 0.5 ampere. These confirm that both R2 and R3 must be in series, and the third resistance must be in parallel with them, like the figure. Okay. We want now to calculate the total resistance. Both R2 and R3 in series. So R total 2, 3 equal summation of them 40 plus 60 equal 100 ohm. Okay. And these resistances in parallel with R1. So R total equal R23 times R1 divide R1 plus R2 with 3 equal 100 times R1 20 divide 100 plus 20 equal 16.67 ohm. This is the total resistance. Okay? Okay. Find the equivalent resistance from the illustrated figure. We want to calculate total resistance. Okay. This problem can be calculated by drawing. How? We can label this resistance 1, 2, 3. Okay. Okay. Both 1 and 2 and 3 are connected in a 1, 2, 3. Connected in a, yes, series. So R1, 2, 3 equal 3 plus 3 plus 3 equal 9 ohm. We can simplify the circuit by like that. Okay. This is the total 9 ohm. Okay. This is 18 ohm, 4 ohm, 5 ohm, 30 ohm, 5 ohm, 10 ohm. Okay. Both of these resistance are 1, 2, 3. With this resistance is R4. Okay. Both of R1, 2, 3 or R4 in parallel. So R dash 1, 2, 3, 4 equal 8 times 18 divide 8 plus 18 equal 6 ohm. Okay. So we can simplify the circuit as okay, this is 6 ohm, 4 ohm, 5 ohm, 30 ohm, 10 ohm, 5 ohm. Both of 4, 6, 5 in series. So our total here 5 5 plus 6 plus 4 equal 15 ohm. So we can simplify the circuit. (15 ohm, 30 ohm, 5 ohm, 10 ohm. Both of 15 and 30 in parallel. So R dash equal 15 times 30 divide 15 by plus 30 equal 10 ohm. So we can simplify 10 ohm, 5 ohm, and the result 10 ohm. Then R total equal 10 plus 10 plus 5 equal 25 ohm. Okay. See you in next lesson. To continue this lesson,